video, we'll be discussing about food technology. And now, food technology encompasses not only the packaging, it also encompasses the preservation. Now, before I dig a little deeper, I just want to define some of these terms. Food preservation is actually a method of storing food for future use. In other words, what we want to do is to remove or minimize the oxidation process of fats that causes odor in food. Now, food packaging, on the other hand, is a process whereby a product is made in such a way that it can be used for a future use. And some of these materials used for packaging, it include glass, plastic, aluminium or wood. And all this is to make sure that the food is well contained, to make sure that we avoid some of the chemical damage to the food. And this really ensures the long life or the shelf life of the products. And the topics that will be highly elaborated on this food technology involves the most commonly used method of preservation. It also involves the newly methods, which is the modern methods of preservation, as well as the highly used methods when it comes to packaging. So these are the topics that we'll be discussing mostly in this food technology. My name is Avelino Mesele, and so
these are the most commonly used chemicals used for food preservatives. Food preservatives are used to improve the quality and prolong the shelf life of the food. And here are the most commonly used chemicals for food preservation. The number one is ammonium sulfate. Ammonium sulfate can be found in bread. It makes the yeast happier, making the bread more happy, more fluffy. And the second one is the L-cysteine. L-cysteine is found in duck feathers and human hair. The amino acids present on those sources makes the food more stable and prolong the shelf life. And the titanium dioxide. Titanium dioxide is one of the most carcinogenic chemicals in this list, making it more dangerous to others. It can be found in milk and dairy products and some cosmetic products. Butylated hydroxytoluene, the number 4, it is found in cereal, cosmetics, and can be used in jet fuel. And number 5, sodium benzoate. Sodium benzoate found in acidic liquors, margarine, and dairy products. It gives antifungal properties and causes tingling effect when you eat the food. And the number 6 is potassium bromate. Potassium bromate can be found in burgers found in fast food chains, and it avoids the oils in the food to be rancid. Number 7, acesulfame-K is an artificial sweetener. It is 200 times more sweeter than the table sugar, yet it is also carcinogenic when in high concentration. The erythrocin is a food coloring. It is commonly found in cherries and baked goods. It is made from coal tar. And last one is the benzoic acid. Benzoic acid is a very reactive compound, and it is found in cheeses and other dairy products. Benzoic acid causes hyperactivity and asthma among children.
These are the new methods in food preservation. First one is the high hydrostatic pressure. The application of high hydrostatic pressure is now well established for non-thermal inactivation of vegetative bacteria, yeast, and molds in food by pressure pasteurization. Vegetative forms of microorganisms are generally sensitive to pressure in the region of 400 to 600 megapascals. The advantage of this technique or this method is that it has little effects on small molecules, making the flavor and the odor remain relatively unaltered. The next one is the ultrasonication. Ultrasonication at high enough intensities has long been known to inactivate vegetative bacteria and to reduce the heat resistance of spores. The effect is amplified by increasing the temperature. However, as the temperature increases, the relative magnitude of the amplification is reduced. Then, the high voltage electric discharges. High voltage electric discharges, or electrophorization, are most effective for the inactivation of vegetative bacteria, yeast, and molds, while the spores are much more tolerant. Voltage gradients in the region 20 to 60 kilovolts per centimeter are used, delivered in series of microsecond pulses at pulse repetition rates sufficiently low to avoid too much heating. And lastly, the irradiation. The use of ionizing radiation, including the gamma radiation from isotopes, electrons, and X-rays from machine sources, is legal for disinfection to prevent sprouting of bulbs and tubers, and for biopressurization of foods in nearly cortical freeze. The technology is relatively simple to apply with straightforward inactivation kinetics and geometry that makes those control and processing requirements much easier than for many food processes.
Biodegradable packaging material coated with antimicrobial agent. This new innovation protects products against microorganisms and its development. So, this packaging material is based on a fibrous substrate coated with a matrix. This coating matrix is made up of one or more biodegradable polymers that allow the controlled emission of one or more antimicrobial agents such as essential oils. So how does this material works? In a packaged product, humidity is always present. The higher the humidity, the higher the development of microorganisms. To counter this, the higher the humidity, this material produces antimicrobial agents to counter the development of microorganisms. Thus, this improves the shelf life of the product.
Hi, my name is Dennis Angelo E. Francisco, and I'm going to discuss about the new materials used for food packaging. So, food packaging nowadays and monitoring are the major focus of food in related to nanotechnology. Packaging with nanomaterials can be called smart, meaning it can respond to the environment conditions or to repair itself or to alert consumers if they are contaminated with any microbial harmful things like pathogens and stuff. Okay. So first example is the use of clay nanoparticles to improve plastic packaging. This plastic is what we call the urethane. Urethane is dispersed throughout the plastic that blocks oxygen, carbon dioxide, and moisture from reaching the food. And then we have another example is what we call the active packaging. It absorbs oxygen to keep the freshness of the food.
different food technology has to be used in order to increase the lifespan of products. Knowing that we are in a world whereby the demand has increased and then the supply is deficit, we really need all the technology from preservation to packaging in order to increase the shelf life of product. Once again, thank you for watching our episode. We see you next time. My name is Avelino Marcella, signing off.